Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good morning. So today we will discuss our second topic. Okay, the first topic is introduction. The second topic is particle rectilinear motion. So we will discuss about the movement of a particle in a straight line. So we call it a rectilinear motion. Before we go to analysis and how to answer the question, I would like to introduce first what it means by displacement, velocity and acceleration, because in the particle, the one that we will analyze is how much the component is displaced from one point, or what is the velocity at time given, or what is the acceleration. So we need to know what it means by displacement, velocity and also acceleration. Okay, we start by the first one. Here, the displacement. Okay, so let's say we have one, this is one component, this is one line, and this is our reference point. Let's say, I call it a reference point. And then we have a particle moving from here. Let's say start from here, moving to the front, and then turn direction, and then stop here, and then turn direction, and then stop here. Okay, so we have this particle, but if the real condition is the particle is moving only in this straight line, but I cannot see if I just draw in this straight line. So what I will do is I will draw a path. We call it a path. Okay, we will offset a little bit the movement so that we can see where it really moved, but in reality it only moved in one straight line. So we start from here, goes, this is point. Okay, so start from here, go to front, turn here, straight up here, and turn and stop here. Okay, so this is the movement. Okay, from here go straight front and go backward, turn and stop here. So this is I draw the path so that I can see where exactly it moves. Okay, so the direction goes to the front, going backward here, and turn going this way. This is the movement. Okay, go to front, turn around to this direction, and to stop at this point. Okay, so what we call by displacement is the measurement of how much this component displays from a reference point. So this is our reference point. So we need to measure how much this point displays from reference point. So let's see if I'm having here is 1 meter, 1 meter, 1 meter. Here's also 1 meter, 1 meter. Okay, so 1 meter. Okay, so let's say we want to have, this is point A. We'll start from here, point A, point B, point C, point D, point E. This is point O. Okay, so displacement, if I'm saying about displacement of point A equal to, okay, so later on I want to put displacement of point B, displacement of point C, displacement of point D, displacement of point E. Okay, when this component is at point A, the displacement is, which is 1 meter from reference point. So 1 meter. Okay, so displacement is 1 meter. Okay, next, if I have B, displacement is 1 plus 1, this is 2 meter, this is 3 meter. Okay, but if I'm taking the displacement at point D, I will not put point D equal to 1 meter, even though the distance here is 1 meter. Okay, because all this one, displacement, velocity, acceleration, is a vector unit, so it must have the direction. You see here, even though the component moving to front, going back to here, Okay, all this position is I'm putting the positive value. Okay, but if for point D it is negative 1 meter, SE is negative 2 meter, meaning that from this reference point to this direction, not the direction, the position at to the right of the reference point will be positive. Okay, position at the left of the reference point will be negative. Even though you see this one, point D, the movement is to that direction, but because of the position is to the left of the reference point, it will be negative. Okay, if I'm taking here, let's say we have one more here, point F, displacement of F equal to, even though it is moving this direction, but because it is to the right of the reference point is 1 meter. So the difference between, there's a displacement. Positive and negative depend on the position from the reference point. Okay, how much it displaced from reference point. Okay, and the other thing is normally the question will ask you about total distance travel. Okay, total distance travel. Okay, total distance travel different from displacement. Displacement you have positive, negative. Total distance travel is only the distance. Okay, so it always be positive. We don't have the direction, but it is a distance travel. What we need to do is you have to take all this value. So for example, total distance travel moving from A to D. Okay, so the distance level here is from here goes there. We need to take all this length. Okay, if the question asks you to calculate the total distance travel, you have to first draw this one, draw the path, and then you can see where it really goes, and then you can measure. In this case, you have this one, this length is the first one, 2, and this length from here to here, it is 3. From here to there, it is 2, and then from E to D, you have plus 1 here. Okay, so total distance travel in this case, so A. Okay, so there's the first one, difference between displacement and distance travel. Displacement, you have positive, negative, depend on position from reference point, but distance travel is only the distance move where the component move. Okay, always positive. This one we can have positive and also negative, depend on the location. Okay, so that is for the first one, distance travel.